And the topic for today is different development methodologies and the development process as a whole. There are a couple of recorded lectures about this on the course homepage, specifically one about different development methodologies. If you haven't watched that one already, I recommend that you do, because this lecture just continues with that one, really. So if you haven't got that context, some of these things might be difficult to grasp. So, development and software engineering. So there's an IEEE standard, of course. There's always an IEEE standard for whatever you are looking for, that defines software engineering as the application of systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering to software. And there are a few keywords here. If we break this down, we can see that there are a few things. First of all, it's a systematic approach. So this means that it's something that we plan ahead of time. We have an idea of what we're doing. We don't just play around until we get an end result. We have a plan. We thoroughly follow that plan, so that we know step by step what we have done and what we have left to do. And through following this plan, we are able to repeat ourselves. We are able to do the same thing again using the same plan, and then we should get the same result, hopefully. This also means that we have a tool for evaluating what we're doing. We can look at the end result, or we can look at the path towards that end result, and we can see what went as we expected it and what didn't go as expected, and what should we do differently next time, so that we can change the plan and systematically introduce this change for future projects. It is disciplined in that sense then, because we do follow the plan. We don't stray from the plan, or if we do, we document why we are straying from the plan and what we have done. So again, that we can follow it and we can see what was the effect of us deviating from the plan we had. Preferably we should be able to measure it as well, which is the next bullet point. While following the plan, it's also important that we keep an eye on the target, so that we make sure that we are working towards the target, that we, in our case, deliver functioning software, for example. That is probably our target. And if we do things according to plan, but we feel are moving us further away from that target, then we should do something about it. Well, development, well, that's what we do. We design and we engineer software solutions. So no point in saying anything further about that. Operation, well, once we've developed the software, that's just the first step, obviously. The next step is that we need to run this software. And these days, especially with cloud computing and so on, it's more clear that running the software is not the responsibility of our customers. It is something that we still have an ownership of. We run the service, we run the software, and we sell access to it, which means that operation is very much part of the responsibility of the software engineering. Even if it were so that we are selling the product as it is to the customers and they are running it on their own, the operation is still in some sense an important aspect for us to keep track of, because if we have the right logs, if we have the right metrics really when running the software, we have input to continuing developing it. We can everything from bug reports to what features sell the most, what features aren't selling anymore, so we can remove them from the product. And as I say, performance measurements, reliability, and so on, all of these things are valuable input to our development process, so that we can systematically learn from the running product and improve the next version of the running product. Maintenance, you hear many different numbers ranging from 80 to 90%, and that of a product's lifetime. So from when it's first developed to when it's retired completely. So 80 to 90% of that time is in some sort of maintenance phase. So the first development is really very short. Some of you may have heard of the year 2000 bug. Most of you weren't even born then, I think. But that was the reason for that. The real reason for why we had this Y2000 bug. The shape of it was that dates were stored with just 2 digits for the year. So instead of storing 1985, you would store just 85. And then, of course, when you rolled over to the new millennium, you started again from 0, which meant that the next year was smaller than the previous year, if you just did an integer comparison there. The real reason for that was that many software systems were built in the early 80s and were still in use at the end of the century. Meaning that no one thought when they were building control software and banking software and so on in the early 80s, that no one thought then that it was going to be used 20 years later, but it was. And that's the problem. And some of these systems are still in use because they are rock solid, completely reliable, and there's no reason to change them. So you will still find some of these old systems running in banks, especially banking, because they don't change things unless they have to. During maintenance, of course, there are many things that can happen. You usually classify the activities into 3 different categories. You have corrective maintenance. That's fixing bugs, really. You have adaptive maintenance, which means changing the product so that it keeps itself current. So when the reality changes, when the requirements from the world around it changes, you adapt the software so that it copes with this changing reality. That's adaptive maintenance. And the last one is perfective maintenance, where you make sure that you do things better. You might have done it right, but you might be able to do it better, cheaper, faster, whatever. So those are the 3 main categories: corrective, perfective, and adaptive maintenance. And most products, if you spend, say, 2 years developing it, developing the first release, well, you're going to spend some 20 years, at least 20 years, sometimes more than that, on working with this code base, building upon it, increasing its capabilities, culling what is no longer used, and so on. And that's most of you are going to end up in a reality where you are working with an existing piece of software. You have this legacy code, you have this legacy system that you have to work with in order to develop new things. Very few of you will have the luxury of starting on a clean slate and doing a completely new system. So maintenance is really where we're all headed. So a friend of mine, or a colleague of mine, Tony Goshek, made this view of software engineering. He actually did it in terms of requirements engineering. And he neglected to name it, so I'm calling it the onion model, just because I like to tease him, where he looked at how you can optimize for the different development phases and different parts of your organization. And by optimizing on one level, you might be sacrificing different levels. So the idea is that the goal of a perfect requirements engineering phase, the ultimate goal there is that you have perfect requirements, right? You've talked to everyone, you've listened to all stakeholders, you've investigated and made absolutely sure that there are no other stakeholders, and what they've said you've written down into proper requirements, and you've analyzed the living daylight out of these requirements. And you've negotiated with the customer and everything, so there's no chance that these requirements are ever going to have to change or be clarified or anything. You have all the information you need. That's the goal of the requirements engineering phase. Obviously, this takes an infinite amount of time. So if you do all these activities for requirements engineering, your project is going to be delayed forever. You're never going to finish that project because you never get past the requirements engineering phase. So already here you need to find this balance between how much requirements engineering should we do in order to get good enough basis to move on and develop the rest of the project. All right. The next level, project. Well, what's the goal of a project? What's the success criteria for a project? Well, it's that we finish on time and on budget, right? If we haven't developed everything, if we're not finished with the development, that's not the problem of the project, right? Because the project would mean that we would just extend the project a bit, or we would even more likely, because if back up a bit, if we're optimizing for the project, we want to finish on time, no matter if we've implemented everything we should. No matter if there are requirements left that we push to the next project. That might not be the best for the product, because then we might release a product with half the features that we want, and some of them aren't even working properly because we ran out of time in the project. So optimizing for the project level might not be the best for the product. Next level, if we optimize for the product, well, we are in some sense sacrificing the success criteria for a project, because we want a certain feature to be there in a certain time frame, because that's our competitors are going to have something similar, for example, and we want to be first on the market and so on. We are going to throw more resources into the project in order to make that happen, even though that will break the budget of the project. For the product, we want to have the best possible set of features, and we want to have them at the right time and so on, even if that means that we cannibalize our other products in the company. So if we develop products that are too similar to each other, we are basically stealing customers from ourselves. And that's not in the company's best interest, even though it might be in the product's best interest. And for the company's perspective, well, the success criteria is, of course, to make money. Make as much money as possible, and that means that we, for example, will put part of our development in countries that might not have as well-defined labor laws, for example, or pollution laws or whatever, and you end up with well, lakes that can spontaneously catch fire, because you optimize for the company but not for the society in which it functions. So the long and the short of this picture is really that we have all these different perspectives from the society. The society have requirements on the company and on the products. The company have requirements on the product and the project and so on. And the products will put what's best for the product will put requirements both on the company and society and on the project and the requirements phase and so on. So these are focus areas that are connected to each other. And in some sense, when we do a development project, we need to balance these. When we do requirements engineering, when we decide what to do, how to do it, and so on, we need to balance these things so that we have a sustainable workforce, for example, that doesn't get overworked and have to leave the workforce because they are burnt out. That's again the project impacting the society. We can continue delivering the product. We can deliver the right thing at the right time, and we can deliver the right thing in the first place. So all of these things are connected, and all of these things are things that we need to put together in our development process. UML, in one sense, UML isn't a development methodology. It's something that you should be able to apply regardless of which development methodology you're using. So you could use Scrum, and you can use UML inside Scrum, and you can use Kanban, and you can do UML inside Scrum or inside Kanban, or you can do some sort of waterfall or iterative development, and UML should be able to support this. Having said that, UML and the unified process do indicate that there are certain steps that has to be taken, and there is some support for iterative development, so some indication that they at least behind the scenes advocate an iterative development. It's not explicitly stated as such that it will only work with iterative development, but there are steps in the process that sort of hint at that they have very much had iterative development in their mind when they developed UML. So the overall process, if we look at the different artifacts produced, is that we do use case diagrams and we do use cases, and based on this we do a conceptual model, and this conceptual model is piece by piece transformed into a class diagram with the help of collaboration diagrams and interaction diagrams. We might throw in flowcharts in the mix, just if we have things that need to be understood as flows. Testing should be there, but it isn't. That is, I guess, a symptom of when UML was initially, when the unified process was initially constructed, because at that point in time, testing wasn't really that well integrated. I think today we would be derelict in our duty if we do not consider testing as an integral part of this entire chain, not only implicitly, because we can use many of these artifacts for testing, but we should make it explicit. When we talk about use cases, for example, we should talk about testing there. Why they implicitly assume that we do iterative development is because when we do the use case diagrams, we of course need to have a fairly decent view of most of the use cases that should be part of the system. Doesn't really matter if we are developing them for now or if we are waiting with the development of them for until a later date. We still want them in our use case diagrams early on. And then it's a matter of picking which use cases to focus on right now, and then define which use cases you should focus on during each iteration in the future. So you do quite a bit of upfront planning there. The use cases themselves are also in that sense how they are described, that you implement first one version of a use case, a complete use case, and then you can iterate that use case, and you can do the different alternative parts and so on through that use case, and that's a subsequent iteration. Of course, you might do it all at once, but you also have the option of doing the happy part first and then the alternative iterations or the alternative flows later on. So for these two in particular, the assumption is that you have an overall view, and you can split that up into smaller pieces, and then you can do one part of this at a time in an iterative cycle. That iterative cycle can be using one of the classic development methods, spiral development methods, or iterative development, or evolutionary delivery, or something like that. But it can also be more modern things like Scrum or Kanban and so on. But it's still, the point is that you do a small piece of work and pull that through the entire chain, and then you go back and take the next piece, and then you pull that through the entire development chain. How the conceptual model and the class diagram is refined with the help of the collaboration diagrams and interaction diagrams. Is also assumes that you have iterations there, that you do one interaction diagram and then you use this to update the class diagram, and then you do the next interaction diagram and then you use that to update the class diagram, so that you successively build up a more complete class diagram. And at any point in time you can also of course start implementing the classes you have with the methods you have at that point in time, based on the interaction diagrams that you have as well. Right, so if we should do this example here, I'll copy paste this. Didn't I have that here somewhere? And put that into some lecture notes. So the idea is, if we use this as an example and walk through this example. Seems like there's something missing here. No, that's it. So if we start with the use case diagram for that, you don't always do this use case diagram. You, in my mind, you do it when you see that you have so many use cases and so many subsystems and so many actors that it's difficult to get an overview. Otherwise, what you would do is basically list what are the use cases that I have against this system. So you would start with just the titles, but let's go the full UML here and do a use case diagram. So what can I do here? Let's see, I don't remember the syntax for this even, but I think I do like this. Something like that, right? These are the use cases. I can log in and log out, and I can roll a dice, and I can calculate the score. Seems like more or less right? We have someone involved. We have the player, and we have relations between player and piece. Let's move the actor declaration up to before this and see what we've got so far, if this works at all. Yep. We would like to add a system border here. I don't remember how to do that, but let's try with I'm going to cheat a bit there. Hang on. Somewhere in here, I'm fairly certain that I've done a use case example somewhere. Okay, yep. That box, that rectangle is important because I want to show which use cases are part of which subsystem. If I have many different subsystems, it's important that I say that these use cases are part of this subsystem and these use cases are part of that subsystem, because that gives me input so that I can start distributing work and decide what to focus on at a specific time. So this is the first step of the development cycle, and then we do detailed use cases, or we do use cases, and then eventually we'll end up with detailed use cases. Use cases are just text, so I can do them in any word processor if I want to. Let's do the roll dice use case. Who's involved in this? That's the player. And then we have a brief description. So the player selects to roll the die, and the system rolls the die and displays the output. This is the high-level use case. It's got a title, it's got the actors, and it's got a brief description of what it's all about. This is fine enough for a lot of planning, and sometimes we might not even go further. In this case, what we can see is that the player does something and the system responds, and there's no back and forth, no dialogue going on there. I press a button and the system responds with something. So I would probably not go further there. But sometimes I have a more complex back and forth interaction between the actor and the system, and then I would add, to make this into a detailed use case, I would add a main course of events. So I'm doing this now for completeness, but in your case, you would probably, the goal of any engineering activity is always to do as little as possible that you can get away with. So if the high-level use case is sufficient for you to understand how to develop this, you wouldn't go further. If there is no interesting interaction between the actors and the system, well, there's no point in going further. You wouldn't gain anything from going further. You would just add to the documentation burden. If you understand enough to start developing, then move on. But in this case, because it is an example, I will continue with the example. So what we do with the main course of events is that we add a table where we have the actor on one side, or the actors on one side, and the system on the other side. So what does the actor do? They select that they want to roll the die, and the system rolls the die and displays them. We usually detail also that it is the player that does these things. And that's it. That's this use case. And then I would move on to the next use case and do the same thing. Start with the high-level use case, and then I would probably do all the high-level use cases first, because that will give me the overview, that will give me some input. I can throw that over the fence into planning and so on. And then if this is the use case that I'm going to start working further on right now, then I would do the main course of events. So that's already here I would split the work and not just do everything at once, because that would do a lot. It would mean a lot of upfront design and upfront planning that would just take time from starting to deliver value to the customers. Then we have the conceptual model. And in the conceptual model, what we want to do is we want to basically look at how does this problem domain look like? Not what am I going to build, or what is important or anything like that. It's just getting an overview, getting a map of the problem domain. And we are reusing, let me scroll up a bit, we are reusing the class diagram syntax here, but we don't focus on that many details here. So eventually what we're going to do is that we're going to take information from the conceptual model and upgrade it into a partial class diagram. So rather than having yet another notation to keep track of, we stick to reusing the notation and being aware of that this is a not yet complete class diagram, and not all of this might even become a class diagram. It's just easier to copy paste once we decide which parts that we are going to upgrade into the class diagram. The way to do a conceptual model is to look at whatever descriptions we have, and a starting point is that we look for nouns. In this case, we have a player, we have dice, and we have a score. And that's actually really it. The player rolls the dice, right? And the dice are added to the score. So I can basically write any description I want on these relations, something that really describes the relation and what is happening there. Again, this is my understanding of the problem domain. It's not something that has to have a complete one-to-one mapping to whatever system I'm building or whatever features I have available in my programming language. So I'm using this to describe what's going on rather than the actual syntax of my programming language. I can hammer out a few details there. For example, I know that a dice will have a current value. Which will give me an indication there as well that I have an attribute there that is a current value on the dice. There's actually a current value on the score as well, obviously. So even here you notice that I start with something, I brainstorm something, and then I add to it as I go. As my understanding of the problem domain increases, I will add to this map. In real world, what would happen is that I would probably do a bit of brainstorming myself. What do I think is part of this problem domain? I will have some of these concepts there. I will have some of the relationships there, and I will start talking to the customers and get details in the use cases from the customers, and then I would go back and revise, and I would add more concepts as I find them or as I learn about them in my customer interactions, or when I read documentation, or whatever I do. During my entire requirements engineering process, really. I would be learning about the problem domain, and I would try to express that into a conceptual model. This is my current understanding of the problem domain. This also means that as I go ahead in the development or in the design, I might pick up new details. I might learn new things. I might figure out that already, so even during testing or implementation, I might learn that my understanding of a particular concept was wrong. So I would go back and I talk to the customers again, and I would update the conceptual model to show that this is the current understanding. This is how the domain in which I'm building the software system works. This is my conceptual understanding of what we're working with. Not all of this have to end up in the code I write. Some of the relationships will be different, some of them will be removed altogether, some of the concepts will not be there or will be different, and some of the attributes will be upgraded into classes and so on. So things will happen between this and what we're actually building in the end, but it's our understanding of the problem domain, not of what we're building, but what reality we are trying to fit our system into. So with this conceptual model and the use cases, we can start looking at in what way are we using these domain concepts to how are they interacting with each other to solve whatever I asked of them in my use cases. And that is well, we call it dynamic modeling. We model the behavior of the system. And in order to do that, we of course need to look at in what way am I actually interacting with the system. So the first part of this is to do a system sequence diagram. Our system sequence diagram is basically it's a special case of sequence diagrams, which you're going to see much more of later. Sorry, but we focus on just that we have actors and we have the system, and what does the system do against the system. So I'll do a brief one for the roll dice. We have a participant. And we have I don't remember. Again, it's been a while since I did these these diagrams. I don't remember the exact syntax, but let's call it an actor, because I think this should be something like that. I think rings a bell. Player calls something on the system. And what do? Well, we do a roll dice. And that was basic. Since this was a very simple use case, this will be a very simple system sequence diagram. Actually, we don't do that. We have the player, which is an actor, same thing as in our use case diagram. Let's see if I'll hide this for you so we can have both of them on the screen at the same time. We have the same player. They do something against the system. They select roll die. In the use case here, we've written it in natural language, in English, and computers are, well, they're getting better, but they are, as a rule of thumb, really bad at understanding natural language. We need to translate this into something that actually makes sense to a computer. What makes sense to a computer? Well, method calls do. So whatever we see here that I'm doing against the system, that will generate some sort of event, system event, or system call, um, from the outside of the system to the actual system. Whatever happens here that generates one of these calls will be translated into a method call. This method call is, in this case, the roll die method, which will be in an object of the type system. So basically what we're saying here is that we need a class called system that will have a method roll die. And if we do this for all the events in our use case, we can do this use case by use case. What we do is that we end up with, and they will all end up in the same system sequence diagram. So first I will do roll die, then I will do check score, and then I will do something else, whatever. All of this will be one system sequence diagram, which is mapped to one use case. This is the system sequence diagram for this use case. And this will give me the input I need in order to move on with my behavioral models, where I will look further into what is going to happen inside the system, which objects do I need to interact with each other in order to solve this task that has been given to the system, the roll die task. So this is actually touching upon a couple of lectures that are up and coming, but just as an example, an illustration of how we are using the UML diagrams and unified process to guide our development, give us the input for the next step. So every step that we follow, we take, has a meaningful activity that will give us more refined input for the next step. And every step we take takes us that much closer to the actual implementation that we're going to do. So you might think that all of this design activities, doing all of these diagrams, it's a big detour from what the customer said to what we're going to deliver. But what we're doing is that we are step by step refining what the customer said into such a format that the actual implementation is trivial. Our understanding is now so complete, and our description is now so complete that the actual implementation should be more or less trivial. So each step, each use case diagram, each UML diagram, and each refinement of these diagrams will bring us that much closer to delivering this value to the customer, this working software that we want to deliver to the customer. So I think I won't go any further with these diagrams now. We will revisit them as we come to the right lecture instead. And I would continue with let's take a break here actually, and then we'll continue with the lecture after that. So let's meet each other at 1:15, and then we'll continue from there. So a few discussion points here. Waterfall, I think I haven't talked about waterfall with you, or maybe I did. The idea that you have a series of activities that you do in that order, and there's no going back and modifying with more information. Strict waterfall is very rigorous and never used in practice, because you always learn more, so you always have a reason to go back and iterate in some form or other. But the good part about waterfall is that we get an overall flow. So if we have this understanding that, of course, we can go back and we can do over certain parts as we learn more information, the good part with waterfall is that we can understand that there is a certain order in which we want to do things, and we have a path forward. So we have an understanding of that. By doing this, we are creating input for the next step, and this next step is the following. So we can keep our eye on the target in some sense by knowing where we're headed. And then, of course, always with the understanding that if we need more information, we of course can go back and get it. So it's a structured approach in that sense. So the waterfall is good for that, at least. Scrum, with your understanding of Scrum, so the idea with Scrum is that you have this backlog of user stories, and you pick a couple from the top at the beginning of a sprint, and then you work on those user stories to the end of that sprint, and you deliver something valuable to the customer where you've completed those user stories. And these iteration cycles are like 3 weeks tops, sometimes even shorter. And if you have that kind of fast-paced development, where would you do design? Some of the design activities are, you can easily say that, well, doing the detailed use cases, for example. So if I have my user stories and or use cases if I want to, and I can pick the top ones and say that these are the ones I'm working on in this sprint, let's do detailed versions of them. And then let's do a conceptual model of just those use cases. Of course I can do that, but when you come to the conceptual model, you really want to have this overall view. You want to add to that overall view, and you don't really know in the beginning, so what, or you can't really focus to that extent on just the part of a conceptual map that fits what you're currently working on. You need to have a broader perspective. So when you do the conceptual view, you need to have a higher overview, which means that you need to take on more than what is just the currently active use cases or user stories. Same thing to a certain extent goes for a few other parts as well. When you do detail, or when you describe these are all the use cases I have, that's also a step where you need to have more of an overview. So for these activities, the Scrum methodology, where you say only work on what you currently have in your sprint backlog, wouldn't really work, because you need sometimes to have this overview. So what many companies do when they develop with Scrum is that they have one or two, usually not more than that, but one or two sprints in the beginning which are longer, that enables them to do some sort of upfront design, just enough to get them by that they have this overall scaffolding for most of the system in place. So a slightly bigger understanding, slightly more overview, and then they can focus on the actual details for each sprint from there on. You would also see in development methodologies such as extreme programming, where they said, oh, we don't have architectures, we don't have design, we have a metaphor. And that metaphor is something that should resemble an idea of the system, so that you can, you know where you're working based on that metaphor. And that metaphor, it's a beautiful idea. I think that the difficulties in finding a right metaphor and describing that and how your system fits into that metaphor is probably as much work as doing some sort of early architectural design. But you might say, for example, that, well, our system is like a flower. You have the user interface is the petals of the flower, and then you have the stem, which is the data transformations, and you have leaves attached to that stem that transforms and filters the data in certain ways, and then you store it in the roots of this flower. And that's a beautiful idea. And then you can say that, well, what are you working with? Well, I'm working with user interface. Oh, that's one of the petals of the flower. As you can hear, I'm not too keen on the idea. I think that a proper architectural design is just as quick to make and as descriptive or even more descriptive, because you don't have to translate between different domains like that. So stick to the problem domain at hand and do a proper conceptual model or an architectural model. Kanban suffers from the same problem as Scrum in the sense that you are taking one work task at a time. So there's nothing saying, there's little room for doing these upfront designs there. So what you would do in Kanban is sort of the same idea as with Scrum, that you actually make sure that you have a work item, which is do upfront design. It's going to be difficult to sell that in because it doesn't deliver that much value to the customer, but the value to the customer is that by doing this activity, you are able to deliver the other activities, the subsequent activities, much faster. So you would put that into the backlog, both for Kanban, and you might do that for Scrum as well, saying do upfront design, and then you would make sure that that one is prioritized, that you start with that one, and then you can do the small level design after that on a use case by use case basis, for example. When you should use which process model, that very much depends on a whole lot of things. If you have a one-off project, you have a customer that walks in through the door and they have a one-off project and you're never going to see them anymore, well, doing Scrum or some sort of iterative development, classic iterative development, is probably a good starting point because it's familiar to everyone. If you have something that you're going to be working on for a longer period of time, and you might not have these collective starting points as clearly cut out, then Kanban might be a good idea. Taking care of support tickets as they come in, for example, would be a Kanban, a very good example of a Kanban flow. So I'm not sure I have a good answer. I posted once that question, and I think I've failed to answer it ever since in my lectures. Let's say limitations. Well, Waterfall has the limitation that you are doing a lot of activities, you're doing a lot of upfront design that you're not sure if you're going to need it in the first place, and you're not sure when you're going to need it. And it doesn't really matter if you do iterative development, you're still doing probably a bit more than you are certain that you have use for. With Scrum, it is reduced simply because you only do the upfront design for the coming sprints. You only do upfront design for the coming 3 weeks. So if you waste that effort, it's not that big a waste. And with Kanban, you don't do any waste. You only do the design for the work task that you have. On the other hand, you lose the overview. You might lose the overview. So that would be the limitation of Kanban in that sense. And then testing. Again, always think about testing. How would I test? How would I test in Scrum? Well, you have the acceptance criteria on the back of the user stories. You would want to set up an automated test system that helps you with doing regression testing, for example, so that you're certain that you don't reintroduce already known bugs. And the same thing with Kanban. With Kanban, it's even more important that you work with the test cases parallel to the new development, so that you always make sure that you have working test cases. To the extent some would argue that you would have working test cases long before you have working code. And that's how you would work with testing like this. Simply because you don't have like in a classic development project, you don't have a month at the end of the project where you will freeze new development and only do testing. It's something that has to be done continuously. Then you would in Scrum and in Kanban, when it's time for a major release, you would probably put in to the backlog system testing. That would be a user story or several user stories that as product owners we want to test the system so that we don't release software with bugs in them. And that would as you're approaching a major release, that user story would become the top priority, and that would mean that you would pick that user story over any new development, and you would do that. But that's how we do it. Testing would be part of every user story, and then doing this big pre-release testing would be a user story in its own right. And then that would mean also that you would need to sell in that to the customer so that you have a customer value. And you need to convince yourself that there is a customer value in doing more testing. But the good part is that once it's in the backlog, it will hopefully get done, or you have a good reason for not prioritizing it. In the big 2-year development projects, the classic development projects, testing was always supposed to be done in the end, and in the end you realized that you didn't have time for it because the new development ran over time. So you have to release something without doing proper testing, and then it was forgotten about instead. Project planning. Well, what do we need in order to plan something? Well, that depends on the task, of course, that we have. But that's the first question that we should ask ourselves when we set up a plan. What do I need in order to be able to do this plan? It can be, first of all, which tasks am I going to do, and how much time are those tasks going to take? What resources do I have available? What dependencies I have on, for example, certain equipment that has to be in place and so on. What ability do these resources have to perform the task? Do they need to learn new stuff, for example? It'll take longer time and so on. So those are examples of things that I would need to have some knowledge of in order to plan something. And sometimes we do these things implicit. If you have to meet a friend downtown, and you know how to make a plan on how to get there and meet your friend on time, because you know how the traffic system works, you know how to get there, and you know how used your friend is to waiting, which is part of the plan as well, to know how close can I hit the mark, or how close can I miss the mark without making my friend pissed off at me. So those are activity or knowledge that you have when you make that plan, and you probably don't do that explicit. You just think that, well, if I'm supposed to be at that and that place to meet my friend in an hour's time, well, I'd better start in 20 minutes. You know that. So without having to detail it. But when you do a big development project, well, of course, there's plenty of new activities and plenty of unknowns, and that means that you need to start thinking about, what do I need to know in order to be able to plan this properly? If I don't know that, well, any plan I will do is more or less meaningless because I will be guessing at the information. And of course, when you're learning, guessing is the first step to learning. One thing you often see when it comes to project planning is a work breakdown structure, which essentially is just that you take the work tasks that you have and you list them on one level, and you take each of those tasks and you break it down. What do I need to do in order to complete this task? And then you break that down into work tasks. And then for each of those work tasks, you break that down into, what do I need to do in order to do this task? Well, and then you have a hierarchy of things that you need to do. In the end, the bottom row here should be on a detailed enough level that you're able to do reasonable estimates on how long will this take, what resources do I need, and so on. So if you think that a certain task is too big to get an overview of, too complex to understand, well, break it down. See if you can find subtasks that are easier to grasp. The estimates that you make on the bottom level are, of course, summed together on the next level, and then on the next level, and the next level, and in the end you have a total sum that this is how long this project is going to take. Do it this way. Don't start with saying that, well, I have so and so many hours, So I will spend, let's say I have 1,000 hours here, so I'll spend 500 hours on this one, 200 hours on this task, and then 300 hours on that task. Don't do it like that, because those kind of estimates have no anchoring in any form of reality. Really, what you want to do is doesn't really matter how long any of these tasks are going to do. This is what you need to do in order to complete that task. So focus on what you need to do first. And then at the leaf nodes at the bottom, do time estimates. How long do I think this will take? I don't care that I have 100 or 1,000 hours. How long do I think this is going to take? And that's your estimate. And when you sum this up, you will probably realize that you end up on a sum which is much higher than 1,000 hours. At which point you need to start prioritizing. What do I have to do first? What can I skip altogether, and so on. But then you're doing that with a much more well-informed material, because you've started from the bottom. You know that this is how long this is going to take. I can maybe take a few shortcuts here and there, but overall this is how long this task is going to take. Doesn't really matter how much they're paying me to do it. This is how long it'll take. So always work from the bottom and work your way upwards. This type of breaking down, doing a work breakdown structure like this, is somewhat from the classical way of software development. When you come to agile methodologies and or extreme programming and so on, they would not focus that much on it. But if you look at a particular task, if you look at a particular user story, for example, if you can't understand a user story, you would probably do more or less the same thing there. You would break it down into smaller tasks. And when you do time planning on a user story, well, if a user story involves database design, graphical user interface design, and so on, you would want to have that at least in your mind, that these are the things I need to do in order to satisfy this user story. So that when you do a time estimate or a size estimate on a user story, you would do that size estimate knowing what your different activities in order to implement that. Again, from classical software development, you don't see these as much in an agile project, but you will probably stumble upon them sooner or later, so let's talk about them for a while. Gantt charts is basically a way of taking this work breakdown structure that you have and then adding some attributes to it. So from left to right here, what I've done is that I've taken the work breakdown structure from the previous slide. There's a feature here that I want to implement my system, search for a room, and I have a few tasks there, and I have subtasks. For each of these, I then do my time estimate. How much time do I think that this activity is going to take? What effort do I think I need to put in there? When can I start it? And then I can calculate based on the start date and my estimated effort. I can calculate an end date. I'll assign a responsible so that I have that in my plan, and I can report as I work on this task. I can report how much time have I spent on it, and I will also report what's my estimated progress, which isn't the same thing as spent time. So with these two, spent time and progress, and estimated effort that I had over here, I can start doing some sort of projection. How long do I think this will take? So if let's say my estimate was that it should take 10 hours. I have spent 10 hours, but reached 50% of the progress. So I'm halfway done. Then I can calculate that this is actually going to take 20 hours to do. And that means that I will be in the end 10 hours over budget. On the other hand, I can do the other way around as well. Let's say my initial estimate was that it would take 20 hours. I've spent 10 hours and I'm 80% done. That means that I am my projected effort is going to be less than 20 hours, and I will have saved some time. So with these simple columns, I can do a bit of calculations, and I can see if I'm over or under budget, or if I'm on budget, time budget that is. And then I can do a fancy graph of this and do a Gantt chart, which basically is the same. Actually, it's less information here. I have my activities. I have dependencies on these activities, and I have my estimates for how long I think they will take. And I'll just chart them into a calendar, start date and then end date based on that. I will list dependencies between them and so on. And this gives me an overview of the project as it progresses. Notice that the focus here is very much on spent effort. And that is something that, again, the Agile community wants to go away from. It's not about how much effort we've spent. It's not about the cost of something. It's about the value we deliver. So they advocate a different way of looking at these things. So they talk about earned value charts instead, where they focus instead on how much value have I delivered. So these Gantt charts and the time reports, the classic time reports, they focus on how much money have I spent, how much time have I spent. They might look at how much I've delivered in some form of quantity, how many lines of code, how many completed tasks or anything like that, or something like that, but that doesn't really say how much value I've added. So earned value charts tries to address this by looking instead at how what value have I created. In order to do earned value charts and in order to size up my user stories, I would use story points. So each user story has a certain number of points. It is a measure of the size of the task. They deliberately say that it's an arbitrary measure. It's not something that should be anchored in how many lines of code I think it should be, or how many people that should be involved in it, or anything like that. It's a guesstimate. I think this user story is this big. Normally they would recommend, or it is recommended that you use a Fibonacci sequence. So you have a few low numbers with which are relatively close together. So 1, 2, 3, 5, and then you run off the scale rather quickly with more bigger and bigger. So 1, 2, 3, 5. There it's important to make a distinction, and then after that it's 13, 40, 100, and so on. So to quickly say that this is a really big user story. And if it's that big, probably what you would want to do is that you would want to break it down into smaller user stories on the 1, 2, 3, 5 scale instead. The amount of story points that you want to assign to a user story depends on the team that you are. So this is not something that can be done company-wide. Each development team has their own velocity, and they assign story points based on their velocity and what they think. So it's not something that management does story point assignment and then, well, here are your 15 story points that you should be delivering to this iteration. This is something that the team decides. They sit with the user stories and they assign story points to them, and then they take on that our velocity is such, so we can do so and so many user stories within the next iteration. Normally, they use something called planning game for this. You can look that up afterwards. And normally what you would say is it would take the first user story and you would assign it some sort of points. If it's a normal user story, if you look at it and say, yeah, this is a reasonable user story, I would say give that 5 points. So you have some leeway to also see that there might be smaller ones, and you have plenty of leeway to say that there are probably very much bigger ones as well. Some say that the first user story you look at should be a 1. It should have 1 point, but then you have no way of going to say that they are smaller. So I would say start with a 5. The first user story is 5 story points. And then the next one. Is it bigger than the previous one or the first one? So my first one is always my comparison then. So the next user story, is it bigger than my first user story? Well, yes. How much bigger? Well, it's really, really big. All right, 40. Next user story, is it bigger than my first user story? No, it's smaller. How much smaller? Well, it's slightly smaller. Okay, 3. So this gives me a reference point, and then every new user story that I assign points to, I can do that relative to my first one. Right, on value charts, and I'm speeding up a bit to get through all the material, but I think you'll follow along. So the idea here is that I start with 0 value earned, and as the project goes on, this is a randomly generated chart, by the way. So, but as the project goes on, I will deliver more and more value so that when the project is finished, I have delivered 100% of the value that I intended. This doesn't really say it's a plan, but doesn't say anything of where I am at currently. So I will add 1 line. Do note, by the way, that the color has changed here. So what was previously the red plan is now the green plan or blue plan. That's I didn't look properly when I generated these graphs, and now I'm too lazy to fix them. But what we see here is that the plan, we follow the plan for the first week, and then we are actually spending more effort than what was planned. So the cost is higher than what we planned for the next week. And then we spend slightly less, but not so than what was planned, but not so much less that we're actually on par again. So we're still over budget at this point. We've spent more resources than what was planned for this week. And as we move along this graph, we see at a certain point here at 8 weeks roughly, we cross, and now we're actually spending less effort than what was planned. And then at week 11, thereabouts, we hit the mark, and at this point we have actually spent as much effort as was planned. And after that, we are consistently spending less effort than what we initially planned. So this is an easy way of, by just plotting these two, we can see, are we over or under budget, or over or under plan at least. We still don't know what value we've actually delivered, so if we add that line as well, yeah, that's now the green line. What we see now is that in the beginning here, so even though we spent more resources than what we planned, we are actually delivering exactly what was planned. So where these things that we delivered here were more costly. What we see at week 6 somewhere, we diverge, so that from there on, what the value we've actually delivered is higher than what we initially planned, which is good, I guess. And it's also at week, let's see, what is it, week 7.5 thereabouts, we enter a point where the cost for what we've delivered is lower than what we've actually delivered. So we're way ahead of plan here. These things didn't cost as much as we thought to develop. And that is something that sticks for the rest of this project, that we are getting away cheaper than what we thought from the beginning, because we're always under the green line. The cost is always under the earned value line. So with these 3 lines, we can quickly get an overview of where we are at this moment. Have we delivered what we expected to? Have we delivered at the cost we expected to? So value charts is a good way of expressing this at a glance, which the Agile community likes. They don't like to have these big tables and Gantt charts and stuff because it reeks of too much initial planning. This one is just enough to get the overview and get the important point across. Are we over or under budget? Often you would see that they flip this around into what's called a burn down chart instead. So the difference here is that we start with saying that we have 100% left to do of what was planned. And then the initial plan here, if we follow that, we are going to work in some way so that we are eventually down to that we have nothing left to deliver. What will happen eventually is that sometimes what will happen is that we will get new user stories, some user stories might be reprioritized or reassessed in terms of their size, and so on. So we would do replans. At this point, week 4, we replan and we realize that we actually had more to do than what was originally planned. So the number of story points left to complete goes up, and we can put this into the graph so we can see that at this point, if we stick to this, if nothing more happens, we are going to be a couple of weeks late. We can see that. And then something happens here again at week 14. We add a whole bunch of new story points. And now we definitely know that we are going to be over budget or over time for a number of weeks. And it is possible to calculate how many weeks and so on, but I think that the Agile community again would say that, well, don't spend time calculating that, get cracking and make sure that you come closer to completing the project instead, deliver value instead of focusing on the documentation of the project. Using this, we can learn a lot. What happened here at week 14? What was this great replan that suddenly added some 25 new story points here, or 25% to the project? What happened? Was it that we had a release a few weeks back, and as a result of that release, we are getting feedback which adds new stories? Or what was really going on here? This will help us do the next project better. This will help us, can we focus more on, for example, certain users or certain types of features or something like that in our initial efforts of understanding the product? We might not get this hump in somewhere, but we will have a smoother plan where we actually follow that plan throughout the entire project. So any of these things going up, or for that matter going down, if we suddenly de-scope a lot of story points from the current release, that is an indication of, especially if it happens often, but it's an indication of that something isn't going as we thought it should. And that means that we should go back and look at what really happened so that we'd avoid making that mistake again. Risk management, lastly. So this is a big topic. I can't reasonably cover it in one slide or even one lecture or even one course. But the long and the short of it is that always when you plan something, when you look at something, try to figure out what are the risks involved here, in terms of, can I complete this on time, can I complete it on budget, and so on, and what obstacles do I see that might hinder my ability to complete this task. Once you know the obstacles, once you know what the risks are, you can have backup plans, you can have contingencies to figure out, what can I do if this happens? What can I do to mitigate the effect? What can I do already now to avoid this risk occurring? And so on. And I will keep tabs of it as I develop. So throughout the entire project, I will look for new risks, and I will keep track of the risks that I had to see how are they more likely to happen now Is there something I've done that will make this risk more likely to trigger, or have I reduced the risk of it happening? So keep track of them. If you've listed them, it's not something that you list in a planning document and then you forget about them because, well, we thought about all the risks, we have them in the planning document. If you've identified it as a risk, it's something that you have to make sure that it actually doesn't happen. So be proactive when it comes to your risks. That's, I think, what I want to say about this. So there you have it. Development projects. I'm stopping the recording now.